Fourier transform of given x of t. See, the x of t is any one function. So x of t is any one function, just we have to find the Fourier transform of the given function. So to find that analysis purpose, first of all we have to write the functional representation, find out the time periods and apply the time periods, then simplify that. So that purpose I am taking one example. So this is one of the previous academic question. So the question is given like this: x of t is given below. The x of t function is given below. Find the Fourier transform of this x of t. So the function is like this. This is the given function. So which is defined from -2 to -1, amplitude is 1 is there, -1 to 1 amplitude is 2 is there, and 1 to 2 amplitude is again 1. So this is the given function. Find Fourier transform of this signal. This is also one of the very important function, right? So these type of questions are expected according to the academics point of view. There we have to apply Fourier transform and step-by-step analysis, then finally we have to write the answer. And we can find this Fourier transform directly also using shifting properties, right? So it takes only one step. One step is enough if you apply shifting properties. So I will explain the using shifting property later. Then first of all we have to discuss here step-by-step analysis. Their purpose, I want to write the functional representation here. X of t. X of t is constant, so just observe the signal. This side it is 0 and it has constant amplitude from -2 to -1. That amplitude is here 1. So the time limits are from -2 to -1. And again it has amplitude 2. So this is 2. This 2 amplitude is defined from -1 to +1. So -1 less than or equal to t is less than or equal to +1. And again it has amplitude 1 amplitude. So 1 that is defined from 1 to 2. So less than or equal to t is less than or equal to 2. And the remaining time period, that means greater than the 2 and less than the -2, it is not defined. That's why I write that like this, 0 elsewhere, right? So to find the Fourier transform of any signal, first of all we have to write the complete functional representation. It should be like this. That means within particular time period, what is the function, how it is defined. So write all those combinations. Then apply immediately Fourier transform, right? So to apply that purpose, again I'm writing here Fourier transform equation. Fourier transform of x of t is x of omega. X of omega. This x of omega, generally we have to write integration is from -infinity to +infinity. X of t into e to the power of -j omega t dt. X of t into e to the power of -j omega t dt. But this function is defined from -2 to +2, so we have to apply these limits and remaining limits are not required. So directly I am writing now x of omega. X of omega. From here onwards. Integration from -2 to -1 within these limits. -2 to -1, how is the function? 1. 1 into e to the power of -j omega t dt. Apply the Fourier transform. X of t into e to the power of -j omega t dt. Plus, and integration is from -1 to 1 within these limits. Integration is from -1 to +1. The function amplitude is 2. So write here 2 into e to the power of -j omega t dt. Plus, and again the function is defined from 1 to 2. 1 to 2, the amplitude is here 1. So right there, integration from 1 to 2, the amplitude is 1 into e to the power of -j omega t dt. And remaining time periods, the amplitude is 0, so that's why that is not required. Just apply these combinations, right? And later simplify this. So in that simplification, just I'm applying exponential formula. Integration of e to the power of -j omega t is e to the power of -j omega t by -j omega. Limits are -2 to -1 plus 2 is constant, take it outside. Then apply e to the power of -j omega t by -j omega. Limits are from -1 to +1. And again here e to the power of -j omega t by -j omega. Limits are from 1 to 2. So substitute higher limit and lower limit, then we will get the standard equation that x of omega is e to the power of j omega, because -1 is there, minus, if you substitute here -2, e to the power of 2j omega otherwise write j omega 2 plus 2 into, substitute higher limit, e to the power of minus j omega minus 2 into, substitute lower limit, e to the power of j omega plus here e to the power of minus j omega 2 minus, and the remaining part is e to the power of minus j omega 1. And please remember, here the denominator part also there, minus j omega, and here it has minus j omega, and here it has minus j omega, right? So just I want to take the common part here, 1 by j omega is outside, and in each denominator minus symbol is there, just so that's why I'm writing in reverse order. So e to the power of j omega 2 minus e to the power of j omega plus 2 into e to the power of j omega minus 2 into e to the power of minus j omega plus e to the power of minus j omega minus e to the power of minus j omega 2. So I have wrote like this. Then observe the powers. In that, here omega is there, and here omega, and here minus j omega, and here minus j omega and plus j omega into 2 is there, and 2 j omega is there. Just I am writing separation, 1 by j omega. So similar equation I am writing at one point here. So e to the power of j omega 2, and this function I am writing here, minus e to the power of minus j omega 2 plus this one. Here e to the power of minus j omega is there, e to the power of minus j omega and minus e to the power of j omega plus 2 into e to the power of j omega minus 2 into e to the power of minus j omega. Now in this case, minus e to the power of j omega, e to the power of j omega plus 2 is there, so 1 cancels, and e to the power of minus j omega, e to the power of minus j omega minus 2, and here plus 2 is there, in that also one is cancels. Then directly which becomes here 1 by j omega into e to the power of j omega 2 minus e to the power of minus j omega 2 plus here, so in this case e to the power of minus j omega and here e to the power of minus j omega into 2 is there. So that's why this analysis I am writing e to the power of j omega minus, from these two, e to the power of minus j omega. Just simplify that here, right? So now this is similar to e to the power of j theta minus e to the power of minus j theta. This is also similar to e to the power of j theta minus e to the power of minus j theta. So these equations are like this: e to the power of j theta minus e to the power of minus j theta by 2j is equal to sine theta is there. Just now I have explained here, right? But here denominator part is not there, that's why I am writing denominator this side, then it becomes 2j sine theta. Substitute that complete equation here, 1 by j omega into 2j sine theta, theta is how much here, 2 into omega, plus here 2j sine theta is here omega, substitute that one. Then take j common, j get cancels. Again this expression is like this: sine of 2 omega is there, 2 omega by, here j cancels and remaining part is omega by 2 is there, so omega 2 I am writing outside, and again here plus j cancels, sine 2 into sine omega by omega, sine omega by omega. Now these two expressions, this expression and this expression, these two expressions are similar to sine theta by theta. Sine theta by theta is sampling function. So now here it becomes one sampling function and here it becomes one sampling function, but here 2 omega is required, that's why 2 divides and multiplies here. So 2 is divides and multiplies here, then it becomes finally x of omega is 2 into 2 is 4, sampling of, what is the angle there, 2 omega, plus there 2 sampling of angle is omega is there. This is one of the repeated question in the previous exams, right? So please go through this one. This is one of the very important. just if you want to find out the Fourier transform of any function, so we have to write the functional representation, later write the basic equation, then apply the time limits, within that time limits given function, and apply integration operation. That means simplify that, then you will get the answer. So Fourier transform of this function is 4 into sampling of 2 omega plus 2 into sampling of omega. Please remember this answer, because I want to explain the same problem using properties. Using properties means using differentiation properties there and using shifting property also there. I will explain that part in after completion of the properties. Same problem, we have to find the Fourier transform using properties. So using properties, these many steps are not required. Directly we can write the answer. I will explain the procedure later after completion of the properties. So please take this now.